For 10.1, we're going to be looking at a radical expression and we're going to be graphing them as well. Radical expression basically is what we know as this square root, this little symbol. But we call them radicals because it could be a square root, it could be a cube root, a fourth root, like it could be many, many roots. So to remember 49 can be written as 7 squared. So that's going to be the square root of 49 will be 7. Let's take a look at something like this. Find all the square roots that equal 100. Basically, which number multiplied by itself is going to give us 100. In this case, we're going to think of 10. 10 times 10 gives me 100. However, negative 10 is also a square root because negative 10 times negative 10 will equal positive 100. Same thing with B. I'm going to think of 5 and negative 5. Those numbers multiplied by themselves equals positive 25. And for C, we're going to say 6 and negative 6. Now, when we see it as a fraction, I'm going to think of the top 25, I'm thinking as 5. 36, I'm thinking as 6. I'm doing the square root of each. So 5 over 6 is a square root of 25 over 36. The other root will also be negative 5 over 6. Keep in mind, I didn't say negative 5 over negative 6 because negative over negative will make it positive. I say the whole fraction, negative 5 over 6. Okay. Now, when we just ask you, like on this previous one, I emphasize find all the square roots. So I was also asking for positives and negatives. When we don't emphasize, we tend to think of the positive value only. So find each square root. So the positive value that multiplied by itself equals 144. I'm going to think 12. Now, for question number B, I see the negative side, but it's outside of the radical. So I'm thinking of this thing in here. And I ask myself, which number multiplied by itself equals 1,024? And that will be 32. Now my answer for the radical is 32, but because of the negative sign outside, my answer will be negative 32. Now looking at C, I'm splitting this in my mind as square root of 4, square root of 4 over square root of 9. I'm going to split by two radicals. So my answer will be 2 over 3. Looking at D, I'm doing the exact same thing. In my mind, I'm splitting the radicals. So I'm thinking of this as 4 over 7. But because the sign outside of the radical, I'm going to say my answer is negative 4 over 7. Even for decimals, 0.81, I'm going to think that the square root of this is 0.9. Keep in mind here that I have one decimal place. In my answer, I have two decimal places. Just keep an eye on that. Now here, find the square root of each radical expression. All I'm asking is find the square root of 13 square. I can do it on a calculator. I can find out what square root of 13. It gives me a decimal and then square it, and it's going to give me 13. The funny thing is that when we squared a square root, I get the number on the inside. So looking at B, I'm going to square everything. So I have radical 29, negative radical 29 times negative radical 29. When it comes to the radicals, radical 29 times radical 29, it just gives me the number on the inside. When it comes to the signs, negative times a negative will give me positive 29. Now here, we are already getting the idea that we get the number on the inside when we have a radical. So for C, when I square that, I'm just going to get p squared plus 1. Now we're going to go in our homework and we're going to deal with rationals, irrationals, and not a real number. Now, rational, what the word rational means is that the answer, I can write it as a fraction of two integers. An integer is it's a whole number, so no decimals, no fractions. It's a whole number with positives and negatives. So all it's saying for rational is I can give you the answer as a fraction of two integers. If I look at example B, for example, radical 64, I know the square root of 64 is 8, but I can write that as 8 over 1. I can write it as a fraction of two integers, so I'm going to call this rational. When we're dealing with radicals, it is going to be a rational only if it is a perfect square. I can think of a number multiplied by itself gives me that answer. Going back to example A, radical 17, I can type it in a calculator. It gives me a decimal. It's not a perfect square. So this is not rational. And that's what we're going to call it irrational. Looking at C, I see that negative sign. If the negative sign was outside, that would be fine. But the negative sign is inside. I'm thinking a number multiplied by itself gives me a negative 25. And we cannot think of one. If I think of a positive number, positive times positive equals positive. If I think of a negative number, negative times a negative, it's still positive. I cannot think of a number that multiplied by itself gives me a negative 25. So now we're going to call that not a real number. Later in this class, we're going to deal with negative radicals, but at least not today. Now here, we're going to be dealing with the cube root. Notice I have a 3 on the outside. This case, I'm asking which number multiplied by itself 3 times equals 8. 2 will be my answer because 2 times 2 times 2 equals 8. The same thing for B. Which number multiplied by itself 3 times equals negative 8? In this case, we're going to say negative 2. We can do negatives on the inside of a cube. As a matter of fact, we can do negatives on the inside whenever the root is an odd number, like 3, 5, 7. When the root is an even number, we cannot do negatives. Looking at example C, the cube root of 216, 6. Now we're going to move to the fourth root. Which number multiplied by itself 4 times gives me 16? If I think of 2 times 2 times 2 times 2, 2 multiply 4 times, that's equal to 16. So 2 is the fourth root of 16. From example 8, I know the fourth root of 16 is 2. Because of the negative sign on the outside, here I'm going to say negative 2. Now, fourth root is an even root. It's an even number. I cannot have negatives on the inside. So, not a real solution on example C. Looking at D, notice I'm asking for the fifth root. Just looking at the radical, I'm asking which number multiplied by itself 5 times equals 32. And I want to say 2. Because of the negative on the outside, my answer would be negative 2. Looking at E, the fifth root of negative 32 is negative 2. I can do negatives because my root is an odd number. Then we're going to learn how to graph these. For x, we have some values here, 3, 4, 7. I'll talk about those in a minute. We have the function is the square root of x minus 3. So if I think of x equals 3, I'm thinking 3 minus 3 on the inside, which is square root of 0, better known as 0. So that gives me the point 3, 0. Now, if I think of x being 4, I'm thinking on the